So today we're going to continue in assignment with assignment number 2 for unit number 6, and specifically talk about scientific notation. This shouldn't be a new topic for you. You've talked about scientific notation both in 6th, 7th, and 8th grade. But let's go ahead and get started. I'm going to present just two options for you here. Suppose that you are offered allowance by your parents. And option A is that you get $100 per week. So every week for a whole year, your parents decide to give you $100. That would be a pretty good option. Option B is that you start off the first week with 1 cent, but that it doubles every week. So the second week you'd get 2 cents, the third week you'd get 4 cents, the next week you'd get 8 cents, and it just keeps doubling for an entire year. But you think about what option would you take? And why. Hopefully you've done that, and a lot of people would choose option A. We have 52 weeks in a year, and so if we take 52 weeks times $100, that's $5,200. So definitely not a bad plan. Very generous of your parents to offer that to you. But let's take a look at the other option and see what happens here. If we're talking about the number of weeks here, week 1, you get a penny. Week 2, you get a penny, but you're going to multiply it times 2, and so that's 2 cents. Week 3, you started off with a penny, but you multiplied it times 2, and then you multiplied it times 2 again. So that's 1 times 2 times another 2, that's 4 cents. Well, another way to write this is 1 times 2 squared. And so the fourth week, you started off with a penny, but you'd multiply it times 2 3 times. So it's 1 times 2 to the third. Well, that's 8 cents. So if we went a fifth week, you'd multiply it times 1 times 2, not to the third time, but one more time. So that's times 2 to the fourth power, and that's 16 cents. And so if we continued this process, I don't have enough room here, but if I went to 52 weeks, then that would be 1 times 2 to a certain power. Now remember, after 5 weeks, we took 2 to the fourth. After 4 weeks, we took 2 to the third. After 3 weeks, we took 2 to the second. So after 52 weeks, we would take 2 51 times. And so it's going to be 1 times 2 to the 51st power. Well, if you take 1 times 2 to the 51st power, this is the number that you get. Now that doesn't show up a lot on your calculators. Your calculator will often show you a different number because it's too big to fit on your calculators. This is the ones period, thousands, millions, billions, trillions, quadrillion. That means that you're going to get 2 quadrillion, 251 trillion, $800 billion, and that's just on the last week of the year. So how do we write this number if it doesn't fit on our calculator? Well, the way we're going to write it is in scientific notation. It's going to be 2.2518 times 10 to the 15th power. And so it's times 10 to the 15th power because when I multiply it times 10 to the 15th, I would have to move the decimal, which is right here between the two twos. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 places. Now remember, that's just what you would get on the last week of the year. That's not the total. That really does beat the $5,200 that you would get if you only got $100 a week. This comes about because this is called exponential growth. We're going to have a unit later on this semester where we talk about exponential growth and how it starts off growing kind of slowly, $2 or 2 cents, 4 cents, 8 cents, 16 cents for the first month, but then it just starts to skyrocket in its growth. And so we'll talk more about that. But today we're going to talk about simply scientific notation and how do we write really big numbers like this number when in scientific notation. So the form for all numbers in scientific notation is simply going to be a number, okay, so a digit from numbers 1 through 9. I'll just say a number followed by a decimal point and the rest of the digits. And then it's always going to be times 10 to a particular power. We're going to talk more about what this is going to look like here in a little bit, but this is something you might want to write down so that every time you write a number in scientific notation, it starts with the numbers 1 through 9, and then the decimal point and the rest of the digits. And scientific notation works for really big numbers. It also works for really small numbers. So the reason we use scientific notation is because sometimes the numbers are simply going to be too big or they're going to be too small to fit on our calculator. So let's take a look at a pattern here and see how to write numbers that are really big in scientific notation. We just take a look at 5. Here's our number followed by our decimal point and the rest of the digits. Here it's 5.2, and we're going to multiply it times 10 to the first. Well, 10 to the first is just 10. So when we multiply a number times 10, it's just like moving this decimal one space to the right. And so this is simply going to be 52. If I take 5.2 times 10 to the second, well, 10 to the second is 100. And so I'm going to take 5.2 times 100. Well, that's moving the decimal 2 spaces to the right, which is 520. If I multiply 5.2 times 10 to the third, that's multiplying it times 1,000. So I'm going to take this decimal and move it 3 spaces to the right, and it's going to be 5,200. 5.2 times 10 to the fourth, I start with the decimal here, but I'm going to move it 1, 2, 3, 4 spaces to the right. So I'm going to have, oops, this is a 52,000. And so all I'm doing is I'm taking the exponent and I'm moving the decimal that many spaces to the right. So if it's 5.2 times 10 to the fifth, I'm going to start with 5.2, but I'm going to move this decimal 1, 2, 3, 4, 5 spaces to the right. And I would fill in the rest of the places with zeros. That's going to be 520,000. All right. So let's just take a look at these two problems here and see if we can convert these to scientific notation. So I'm going to start with the first one here, and it's 820 million. And so I'm going to start with a decimal, or a number between 1 and 8, or 1 and 9, which is 8, and then my decimal, and then the rest of the digits. In this case, it's just 2. I'm going to multiply it times 10. Well, if I put the decimal here between the 8 and the 2, I would have to move it 1, 2, 3, 4, 5, 6, 7, 8 spaces to the right. And so it's going to be 8.2 times 10 to the 8th. That's the same thing as 820 million. Well, then over here I have a number in scientific notation and I want to put it in standard form, which is as a regular number. So if I make it 7.28 and I multiply it times 10 to the 6th power, that means I'm going to move this decimal 6 spaces to the right. So that's going to be 1, 2, 3, 4, 5, 6 spaces to the right, which means I'm going to have several zeros in there. Here's my decimal. So I'm going to have a comma here and a comma here. That's 7,280,000. So this also works for smaller numbers. So let's say, for example, I take 4.3 times 10 to the negative first. Well, 10 to the negative first, remember, is the same thing as 1/10. So if I take something and multiply it times 1/10, that's the same thing as dividing it by 10. That's going to move the decimal 1 space to the left. And so 4.3 times 10 to the negative first is going to be 0.43. If I take 4.3 and multiply it times 10 to the negative second, well, that's 100th. That's like moving the decimal 2 spaces to the left. And so if I move it 2 spaces to the left, it's going to be 0.043. If I take 4.3 times 10 to the negative third, that's going to be moving it 3 spaces to the left. So I'm going to have 0.0043. And then 10 to the negative fourth is going to be 0.00043 because I took the decimal and I moved it 1, 2, 3, 4 spaces to the left. And so let's practice these with 3 and 4. Convert between standard form and scientific form. This is standard form here. It's 0.000738. Well, in scientific notation, I want to write this as 7.38 but that means I would have to, to get the decimal where I want it to be, I'd have to move it back to the left 1, 2, 3, 4, 5 spaces. And so I'm going to multiply this times 10 to the negative fifth. So if the exponent is negative, I'm working with really small numbers, and I'm moving the decimal to the left. So this is 7.38 times 10 to the negative fifth. Here I have a number in scientific notation, and I want to put it as a regular number. I'm going to start with 6.2, but what I want to do is take this decimal and move it 4 spaces to the left. So it's going to be 1, 2, 3, 4, and my decimal is going to be here. It's going to be 0.00062, and that is a number in standard form. So let's take a look at one more example. How many seconds are there in 1 year? Well, we know that there are 60 seconds in a minute. There are 60 minutes in an hour. There are 24 hours in a day, 365 days in a year. So we're going to multiply all of these things together to figure out how many seconds there are in a year. So I think I said 25. This is actually 24 hours in a day. So if I take those and multiply them together, I would get, as a regular number, 31,536,000 seconds in a year. So it may not seem like a lot, but that's the truth. 31,536,000 seconds is a year. And so in scientific notation, I'd write this as 3. I'd put the decimal right here because I have to have it after the first decimal point. And then the rest of the digits, 1536 times 10 to a power. If the decimal is here, I would have to move it 1, 2, 3, 4, 5, 6, 7 spaces to the right to get it to where it's supposed to be. And so it's going to be times 10 to the 7th. And so that number could be written as 31,536,000 or 3.1536 times 10 to the 7th. Both of these numbers mean the exact same thing. They're just written in different ways. So your homework assignment for tonight is to work on numbers that you can write in scientific notation, and that's what we're going to be working on. So good luck with that, and we will see you tomorrow in class.